All right, welcome to the free fall practice problems here. I'll do this one in 3 different videos because there's 3 questions here. And don't get the idea that these are just assessment questions that I've warmed over with some new verbs, things like turkey, Oh no, these are totally different questions. Okay, so we shoot this turkey up. It goes up, remains in the air for a total of 6.32 seconds before coming down to the same elevation. So let's draw a little picture. Over here, right? The turkey goes up, some height, right? Goes down. And if that takes a total of 6.32 seconds, I'm basically answering this question here. What is the greatest height that it reaches? Okay. What I can do is I can go from the ground to the top, right? Right. And if I do that, if I go ground to top, it actually takes half the time to go up and half the time down, right? So it's 3.16 seconds up, 3.16 seconds down. And this is true if this is the same elevation as this, okay? So that's what I'm going to do. I'm going to go ground to top. So the final velocity, right, the acceleration is negative 9.81. Right, the time to the top is 3.16. My initial velocity is, I don't know, but at the top, it's 0, right? Because if it's not 0, it's not at the top, is it? Right? Okay, so now to figure out the greatest height it reaches, I want to use something what do I use? I want to use no u. That's a problem, right? I don't have a no u, correct? So to find s, I'm sort of in a tough shape. I guess I could go down, right? I could go from the top down. Let's just go with this, though. Let's figure stuff out here. So I think I'm going to figure out the initial velocity is what I'm going to do. Okay, so let's do this one first. Okay, so finding the initial velocity, I do this. V equals u plus at. Right, the final velocity at the top is 0 equals u plus negative 9.81 times t. So sometimes you do this question first. That's interesting. Okay, it's tricky stuff, right? Oh, and then my time, sorry, my time is 3.16. Okay, so here we go. It's and I get 30.9996. Is that right? 3.16 times 9.81. Yes, it is. That's a crazy number. Okay, and that's meters per second, right? Okay, so that's this answer here is 31 meters per second, right? Okay, and then let's figure out this displacement, right? The displacement's going to be, well, let's see. I guess I would use, I could use S equals U plus V over 2 times T. I don't really have any good options because I don't have a no U, right? So that equals 30.9996 plus 0 over 2 times 3.16. Okay, so here we go. Let's try that. Okay, divide that guy by 2, multiply by 3.16. I get 48.979. Okay, so now the answer here is 49.0. I guess if you had to round that to this place, you'd get 49.0. Okay? Now, it says, what is the displacement exactly 5 seconds after it's launched? Okay? What we need to do for this guy is we need to use this velocity here, that 30.9996. Now I'm going to hit erase, okay? And then I'm going to use that value there, okay? We just got to have that. So here we go, right? Okay. So this we now know is 30.9996 meters per second, right? This is, we know that's 9.81, right? And we're going from the ground to 5 seconds. Okay, so the time is 5 seconds. Right, and then we just want the displacement. We don't want to use one that requires us to know the V, so we use S equals UT plus 1/2 AT squared. Okay, so let's see, it is 30.9996 times 5.00 plus 1/2 negative 9.81 times 5 squared. Okay, so 0.5, whoops, clear. Let's go that thing. 30.9996 times 5 plus 0.5 times negative 9.81 times 5 squared. I get 32.37, right? And that's meters, so 32.4 meters with 3 sig figs would be correct. Hope you enjoyed problem 1 from the free fall practice problems. Let's draw a little dog. Arf, arf.